So we are done now. We set up everything on PC and we moved the work order to the portable calibrator. Just a small note, when you connect the USB cable, which is the USB we supply with the Genie, you simply need to, let me connect it. Yep. You simply need to set up the instrument to accept the USB as communication. So I'll be using the mouse today. From devices, you will set up the USB client port to be communications. If it was in the active sync or the storage device, it will not communicate with the Foresight software. Then you go and press on send to portable instrument as we did, and here we go. Now the technician, which is Sanjeev, will take the equipment and go to the instrument. I have got the instrument here, which is the Yokogawa temperature transmitter, and I need to start the task. Basically, we need to go to the documenting, then run procedure. We will find the tags which will show the calibration works pending. So as you can see, the first one, it was done because it has a fail on as found and pass as left. I have two more to go. So today we are calibrating IWT number 1. Here are the data: plant, location, input, output, number of points, tolerance, device under test serial number, the user ID, the ambient conditions. So we should match the serial number mentioned here with the serial number on the instrument, so we can avoid human errors, especially when the customer is using the same instrument in the same location. So let's press this start button. Check test details are correct. We already checked that, so okay. Then start again. Okay. Now it is loading. Good. It will set up the channels automatically. Connect device under test. So now I need to connect the inputs and outputs. So the input is RTD. I have got two test leads and connected that to the terminals in the instrument. And the output I have is a 4 to 20 milliamp, which will be connected on channel 2. So here we go, I'm done. The instrument is connected. Okay, good. So now the instrument is on because I got the power from the Genie. Suppose that I forgot to set up the external power. I can simply go to the settings here, activate or remove the loop power, and activate or remove a hard if I'm doing the calibration over a hard loop. In this case we need the power supply, so let's keep it, and hard resistor will make no change. So as you can see, the first point is 0 in our calibration. If we look at the input in channel 1, the RTD, the reading is on green, means that the set point is within the tolerance allowed, and the output is good also because it's in green. It's like 4 milliamp. We press on this to save the point. Then it will be automatically taking the instrument to point 2, which is 25 degrees Celsius. We should wait for quite some time. Depends on the instrument's settling time. So let's assume it is 10 seconds. Okay, so the reading is getting stable now. So let's take the next point. As you can see here, before we take the next point, the input is fine. The output is having a 20% tolerance. 20% as tolerance means that it's out of the tolerance we set up in the foresight, means that it's a fail point. Let's do the next point. It will give me a warning because the reading is out of the test point tolerance. So should I accept it? Okay, let's accept it now. So we can go and report that there is a failure or out of specifications on this specific instrument. The second point also is having an error. Let me be patient and wait for the settling time. So in this point it should be 12 milliampere, but it's 11.92. It could be accepted if we already set up the error to be in that limit, but in our case we have set up a 0.1%, which is relatively high in process industry, so that's why we are getting fails. Okay, no problem. So let's go to the next point now. Accept reading, yes. It will take me to 75. It should be 16 milliampere, but it is also out of tolerance. So as you can see, the error is increasing by time. Means that there is an indication that 0 point was fine. The full scale is having some error. So this is an indication you can read before you can see the results, because the error is increasing by time. Then accept reading, okay. The last point is 100 degrees Celsius. So it's also getting bigger error, which is close to 1%, which should not be in critical applications. So I think we are ready to take the reading. So I have set up the points to be up and down, so we can also check the hysteresis. So down to 75, wait for 10 seconds, and then take the next point. Again we are getting error in negative, and this is normal because the performance is having some requires some adjustment. This does not mean that the instrument is having bad hysteresis. As we can see, the readings are close to the upscale as we go down. So 11.92, same like we got in upscale. Yes, the next point. Now I'm getting an error, and as we discussed, it looks like a full scale error. Okay, stable. Next point at 0 degrees. Then as we wait, it's going to green, means that the 0 point is fine, and this gives an early indication that we need to look at either a trim or a span or full scale adjustment, which I believe is the case. So here we go, we are done. Then you click on the disk to save. So we have the as found. We can view the results. We can view a table of the results, or we can view it as a graph. This is the graph for the error. As we go in the span, it will have bigger error. Okay, exit. We already saved that. Exit the procedure. Yes. Now this is a smart transmitter which accepts hard. So we need to go to hard and try and make the adjustment. So in custom task, I'll select the hard. Good. Then we need a power supply because there is no process power supply. Okay. And I need a hard resistor, which is necessary because we don't have also hard resistor in the test leads here. So in the settings, the resistor is already there. Okay, so we can start, wait for the hard function to start, and so we got that on address 0. Okay, great. So let's take a look at how can we adjust that in the device setup, basic setup. Let's take a look at the range values. In fact, I have, as we can see, the error is at the full scale. So when someone has adjusted to be at 101 degrees Celsius instead of 100, and this might be the cause of the error. So these are human errors which might happen. That's why getting a calibrator like Genie with hard capability will allow us to do the calibration communication in a one shot with no need for connecting and disconnecting. Also getting a foresight so we can set up the tolerance will tell us if we have a pass or fail without a need for getting a table, doing a calculation and calculating the error for point by point. This will save us time, this will avoid human errors, and this will be all documented in the software, as the data stored on the Genie will go without any user interruption to the foresight. Good. So let's adjust this to be 100 instead of 101. Set. Okay. So let's apply the values. Now the point was done. Let's go back and do the calibration again. So where can we find this? On documenting, run procedure, we will find the tag. See, as found is failed, as we did, and we found failed. So let's do the as left. It's the same procedure. 109 points. Check details, we checked already. Start. Connect device under test, we already done. So the 0 point is fine, as you can see, and it's stable, the reading is stable. So let's take the next one. Let's go to 25. Great. So we are getting green indication on the output, means that the output value is within the tolerance. Next point, which is the 50 degrees, it should be 12 milliampere, sorry. So it's also within the limits. Let's get the settling time, and then next point, 75, 16 milliampere, it's also fine. If we look at the first two digits, it's fine, and also it's within the specifications, as we can see from the indicator here, the error indicator. Happy with the reading. Next one, 100. It's also giving us good results on the full scale. Let's do the downscale now. Okay, happy. Down 16 is fine. Wait for the settling time. Just observe the readings if you remember, and tell me if there is any hysteresis error. But we don't have to memorize with foresight. Everything will appear on our system when we go back and upload the results. So next one, 50 degrees. also within the specifications, it's green. As we are getting more settling time or close settling time to the specifications, we are getting better performance. Okay, 1201. Go to the 25 degrees Celsius point, which is also 25% because the full scale is 100. So 8 is also performing good. Now the last point is 0, which I assume it will be good as well. And here we go. Last point, save. Good. So as found and as left is there. We can view the as left, as found and as left. See, the error is all below the 1%. So the 0.1% which we have set up. So the genie has done the calculations on our behalf, has tell us it's pass or fail on the field. No need to disconnect, no need to calculate, no need even to take readings. Everything is done automatically here thanks to the foresight combined with the genie. See, the error here is relatively large compared to what we used to have, and that was because of a 1% only error. So instead of 100 degrees it was 101, and this shows us how critical is the calibration for the instrumentation and decisions taken by that. So we are done now. You can also see the graph. See, the error is within the specifications. We don't have any red. Exit procedure. Yes, we are done now. So go back to the office, connect the USB cable, which we did not disconnect, and the user needs to go to his PC and simply adjust the genie, adjust the foresight, to take the readings. So we will continue that on the PC. It will be clear. So thank you for being with me. We will continue in a second.